Lesson 25, Monomial Factoring, Cancellation, and Parallel Lines. To begin with, let's review what a GCF is. It's the greatest common factor. It means what every term has in common. So when we're asked to factor 4ax squared plus 4xy, we want to find the GCF. What's the greatest factor, number, and variables that occurs in each term? Okay, so the number is going to be 4. GCF 4 is the largest number that goes into each term. And then let's see, A, we're not going to include A because we don't have an A in both terms. And let's check the X. So we've got an X here. What's the highest power of X that occurs in both terms? And that would be a power of 1. So 4X is our GCF. We're going to factor that out of both terms. That means we're going to divide it out. So if we divide out a 4 out of the first term, okay, that's going to be a 1. If we divide, let's see, an x out of an x squared, we're left with just 1x, so x to the first power, which leaves us with 1ax, or just ax. All right, the next one, let's factor a 4x out of 4xy. So if we divide out a 4, we have 1. If we divide out an x, okay, that goes in one time. And so we just have a y left over. So ax plus y. We can actually check this to make sure we did it correctly. We can go back and distribute. Okay, what would we get if we multiply 4x times ax squared? Make sure you get the original term. And then 4x times y, make sure you get the original term here. All right, example 2. Here's another one, a little more complicated. First, we're going to look for the GCF, greatest common factor. Okay, so first we're going to look at numbers, 8, 6, and 2. What's the biggest number that goes into 8, 6, and 2? So that would be 2. All right, next, looking at this first term, we have an m variable. So look at all of your m's. Okay, what's the highest power of m that occurs in all 3 of those terms? That would be m to the second. Do the same thing for all of your terms. So I've got an x, x squared, and x. So I can only take one single x out of each. And then let's see, check your y's. Y to the 5th, y to the 1st, y to the 1st. The highest power that occurs in all of them together is a single y. All right, let's get our parentheses ready. We are going to factor out. Factor out the GCF out of your first term. Okay, so we go 2 goes into 8 4 times. M squared goes into m squared once. X goes into x once. And y goes into y 5th. Y to the 4th times. Okay, so what we have left is 4. So 4 times 1 times 1 times y to the 4th. All right, next up, let's factor out the GCF out of our middle term. So 2 goes into 6 3 times. M squared is next. All right, so we've got m to the 3rd. So if we take out 2 m's, we'll have 1 m left over. So let's just cross off that exponent there. Next is x. If we take 1x out of the term, okay, we'll just have x to the first power. So let's cross off the exponent of 2. And then if we take out a y out of here, that whole thing goes away. All right, so 3 times 1 for 3. And then what we have left is x and m. All right, and lastly, 2m squared xy out of, let's see, 2x y m squared. That's the same exact term, just in a different order. Variables are in different order. Okay, so everything comes out just one time. So the minus stays the same. minus, and then 1. Let's go back and check this. So if we multiply back, we should get our original first term. If we multiply GCF by the middle term, we should get our original second term. And if we multiply that third term there, it's just times -1. So I do get that last original term with a negative. All right, let's talk about cancellation. Proper cancellation, here we go. Let's read together. Remember, we cannot cancel the 4s in the following expressions because addition and division are not inverse operations. So division is what happens when we cancel, right? We talk about cancellation of, so we cancel common what? Common factors. What's a factor? A factor is a number or numbers that are being multiplied together, okay? And so you can cancel, which is division, common factors, numbers that have been multiplied. So when we look at this first expression here, x plus 4, nothing's being multiplied, okay? These are two terms separated by a plus sign, okay? So we cannot divide out. We don't have any factors, okay? So that does not work. No. Same here. Well, you might say, well, the 4 is being multiplied by the x. True, but this is still a term, and this is a term. Okay, so these are being added, so we cannot cancel here. Anytime you have a plus sign, okay, so yeah, basically, let's say you have more than one term in the numerator or the denominator, you can't cancel. But we can cancel the 4s in the following here. So see how in this one, we've got the 4 times what? Times parentheses. So we don't even care what's in the parentheses. We know that 4 is being multiplied by stuff in parentheses. 4 is being multiplied by something. Therefore, 4 is a factor. Okay, so as long as everything is in factored form, we are allowed to cancel. So in this case, we can cancel there. Okay, so 4 goes into 4 once here, once here. If you forget about the rules about canceling, you can check with easy numbers. So get rid of the x's and just think about numbers. Okay, so 6 plus 7 over 7 on the left, and then we'll multiply 6 times 7 over 7 on the right. So what is the real actual answer on this first one? 6 plus 7 is 13, and then over 7. So that's the actual answer. What happens if we incorrectly cancel? We go, oh, 7 goes into 7, once here and once here. Well, then we would have 6, the numerators would be 6 plus 1 for 6, 6 over 1. Okay, so clearly not even close, right? Not equal to the exact answer, the actual answer. Let's check out 6 times 7. Let's figure out what the actual answer is. 6 times 7 is 42, divided by 7 is 6. That's the actual answer. What happens if we cancel? Boom, boom. Everything's factored here, right? Factored form. Stuff's being multiplied. So 7 goes into 7 once here, once here. Numerator, I have 6 times 1 for 6. Okay. Oh my goodness, I just noticed on this other example, 6 plus 1 is 7, but still not even close. I think I was thinking of sometimes what people do is they'll just cross those off altogether and not put the 1 here. All right, at any rate, we should notice that it does not work on the left because nothing's being multiplied. It does work on the right. So with that, let's do a cancellation problem. It says, if possible, let's cancel if possible, and we're going to throw in some x's here. All right, can we cancel? Well, let's see. What we can't do, remember from the last slide, is we can't do this. Okay, that is not allowed. However, you should notice, and hopefully you do notice, that you do common factor. You have a GCF, greatest common factor, in all three terms is what? X squared. So we have an x squared. Let's factor it out of the numerator. What's left over? 6x plus 1. Okay? Numerator's factored, copy down the denominator, and now that this x squared is multiplied by stuff in parentheses, it is now a factor, and we're allowed to cancel. X squared goes into x squared once here and once here for our final answer of 6x plus 1. Okay, what we see kids often do, what we see students often do is do this. Boom, boom, boom. Okay, and so x squared, it technically, it does work, but it's improper. Okay, so what are you left over with? 6x plus 1, which is this, but it is mathematically incorrect to do it that way. Okay, so please do it the proper way. Factor out that GCF first. All right, what about this next one? 6a squared, oops, where did it go? Come back. 6a squared plus x squared all over x squared. What do you think? This one's actually done. Okay, there's nothing to do here. I can't do this. We already know that. It's not allowed. And we cannot factor out a GCF. There is no GCF, so that one is done. All right, let's end up with some geometry. Let's talk about parallel lines. They tell us that triangles are similar because of congruent angles. So we've done lots of things with similar triangles, overlapping triangles, what have you. Now we have some triangles where two of the lines are marked as parallel. No other angles are marked, but you should know that these are similar. Why? Because go back to what we learned at the beginning of Algebra 2. We learned about parallel lines. So if I extend these out, do you see that we have parallel lines, and this would be a transversal here, this would be a transversal here. Once you notice that, you're like, oh, parallel lines and transversals. So we know we have special angle pairs. So we have corresponding angles here and here. Okay, so in that small triangle and the large triangle, they share two congruent angles. And what does that mean about the third? The third angle is congruent as well. Also, this is a shared angle that appears in both large and small triangles if we were to draw them separately. Okay, they've always got that shared top angle. Okay, so we have similarity. So when you see a picture like that, two triangles with parallel lines marked, you know they're similar. This one is also similar. This set of triangles here, obviously not the same size, but the same shape. How do we know that? Let's do the same thing. Let's extend these parallel lines. It's a little bit easier to see if you extend them. Oh, parallel lines, you see inside? Parallel lines cut by actually two transversals. So let's take this transversal here, and highlight it in red. Okay, that's my transversal. Here's my two parallel lines. So look inside the parallel lines. Do you see alternate interior angles? Boom, boom. Alternate interior angles. Yes, yes, yes. We also have, what are these called? Anytime two lines cross, we have vertical angles. Okay, and whenever we have two angles congruent, what does that mean about the third angle? It is also always congruent. Okay. So we have, and also, by the way, these are also another pair of alternate interior angles with this transversal here. Oops, sorry about my lines. You get the idea. All right. So with that, let's end with our final example, find x and y. So here we have those overlapping triangles, no angles are marked. However, we have parallel lines. So we can just say, hey, I know that these are similar. And so we'll just match up our corresponding sides and go to town. All right, what do we always recommend? Redraw each triangle, large and small. Label the sides. So we have small triangle, 4, 5, 7. Large triangle, okay, that left side, we're going to add up the pieces 3 and 4 for 7. Okay, and the right side, we're going to add up the pieces 5 plus x. Don't tell me it's 5x. It's not 5 times x. You're adding those two pieces together. Okay, and the bottom of the big triangle is y. So once you've got that all set up, you've got your ratios. Okay, so I'm going to do small triangle along the top. We have sides of 4, 5, and 7. Okay, and let's go get our corresponding sides. What goes with the 4 is the 7. What goes with the 5? The 5 plus x. And what goes with the side 7, the small triangle? That's going to be the y in the big triangle. Okay, cool. Let's solve for, let's go ahead and solve for x first. So we're going to go ahead and grab that ratio where the x is and set it equal to the ratio that we know. Cross multiply. Okay, so we're going to do, I'm going to take it over to the left here. So 4 times 5 plus x equals, cross multiply the other way. Oops, 7 times 5. And here we go. Distributing on the left, we have 20 plus 4x equals 7 times 5, 35. After you subtract 20 from each side, you're going to have 15 left on the right. After you divide by 4 sides, we have x equals 15 fourths. All right, let's solve for y. All right, so we have to go get the ratio where y lives and the ratio that we know. Okay, set them equal to each other and cross multiply. All right, so 4 times y equals, cross the other way, 7 times 7. So 4y equals 49. Dividing both sides by 4 then gives us our solution for y. Y is 49 fourths. So remember we said that we're going to end up with a lot of fractions in this class as answers. Okay, so just leave it as a fraction in fraction form. Reduce always if possible. But there you go. There is x and y. And lesson 25 is in the books.